So at this point, they're going to only use the Leibniz notation, the dy dx stuff.
Okay.
So they're going to take the derivative implicitly. And I think the easiest way to see that is with this example. So find dy dx. So we're no longer just having one variable and taking a derivative with respect to x. We're taking the derivative of every term. In this case, it will be respect to x, but they're not all the x variables.
Okay.
This one makes it implicit. Like you can't just solve for y like we've been doing. So every example you've done before was solved for y. That's why it was just we were just dealing with x's and doing the power rule and all that stuff. Now we are not able to do that. So by implicit differentiation, okay. So this is what you're gonna do. Notice how there's no way you can solve for y. Um, well, you kind of could, but you'd have all these weird square root stuff everywhere. So technically, you'd have two separate functions.
Yeah, I kind of remember that. Oh, those were weird.
So yeah, you have to do it implicitly. So just picture you're doing derivative of each one with respect to x separately. Everything will be the same except when you have the derivative with respect to x of a different variable. So see how these don't match. So y.
Yes.
And this one does match. So this will be just business as usual. Just a power rule. So you just bring down your 2, subtract 1, you get 6x, right?
Yep.
Now this it will be similar. It will be 14y, but you're going to tack on kind of like a chain rule. It'll be dy dx equal to 0.
Okay. Why is it equal to 0?
Well, the derivative of 1 is 0.
Okay. Yeah, that makes sense.
But the only new thing that we're doing here is this piece right here.
Okay.
You take the derivative of y, 7y squared with respect to x. So it creates a chain rule.
All right, I get it now.
So that is implicit differentiation. That's done. Now just solve for dy dx because that's what they want us to do. So move that 6x over. Subtract 6x, right?
Yes.
Divide by negative 14. I skipped some of the algebra. Let me know if you need me to show the work.
No, I got it.
Okay, so we get to there. So our solution, the derivative of y with respect to x, is going to be positive 3x over 7y. Does that make sense?
Yes. I'm doing the first one on the homework, and it's right. Okay, awesome.
Cool. Go to the next page to do a harder one. This time it'll have product rules and it'll be uglier. But in essence, this is what you're going to do. I'll turn the page in just a moment. All right. So you get clue number 1.
Yes.
All right. Same question. Find dy dx. I'm not going to write all the old details, but well, I guess I can. By implicit differentiation. Okay. So same thing. Take the derivative of every single term with respect to x. But notice right here you have a product rule that will trigger, right?
Yes.
So the derivative of this, you got to do it this way. I'm going to use the, make it easier. You take the derivative of the first term, right? Times the second plus derivative of the second term times the first term. Same thing over here. Derivative of this guy times the second term plus the derivative of the x times the first out of space. Then the right hand side will be 0. So do you see that I did product rule here, right? And here.
Yeah.
I use the quotes just because I'm out of space, but technically each quote should have a dx instead. So in front of this term, it should be d dx of this guy, right?
Mhm.
There's just a safe space. So now this derivative is just 14x, right? Times the y.
Yes.
Derivative of y, well, that's just y prime. In other words, dy dx. Derivative of this, 14y would be the derivative, but then you tack on the dy and dx.
Why is it 14?
Oh, I don't know why it is. It should be 4.
Okay. That's because you probably did the 7 and just still had that in your head.
I guess so, yeah. I think so too. Derivative of this is just a 1. So it's gone, right?
Yes.
So at this point, the derivative is done. You're cool with the product rule and the implicit rule.
Yep.
Okay. So at this point, just solve for dy dx, which is an algebra problem, right? Get these on one side, everything else on the other side. So I'm going to subtract this dude and that guy over there. Forgot I said it's going to move everything. I'm moving this guy over here. Moving this one over here. Right?
Yeah.
Now factor dy dx and divide this garbage. On the right hand side in just a moment. So once you divide, you will get dy dx equal to negative 14xy minus 2y squared over 7x squared plus 4xy.
Sounds good.
And any issues with the steps or the algebra?
Nope.
It's not right. Implicit's not too bad, right?
No. This is just taking what we've learned and smashing it together.
Pretty much. So you have one new rule, which is the dy dx thing, and you're applying it to chain rule, product rule, quotient rule, basic rules, whatever. Whatever shows up, you just got to do it. Okay. Let me open the homework. But yeah, that's pretty much it over and over again. Let's see here. Let me show you the. Can you see the homework?
Yes.
So yeah, the first couple, that's all you're doing. Here's another product rule. You just, once you're done doing the implicit piece during the product rule, gather the dy dx's, and then solve for this. That's it. Here you're gonna have a chain rule, and then during that chain you'll have a product. Same thing over here. Well, here it'd just be actually just a product rule, and then you'll solve for this guy. But yeah, do you want to do one more, or do you want to move on to something else? Does this make
We can move
sense?
on. Yes.
Okay. Okay. So I think we're on week 6. So let's do the implicit part. Okay. We did implicit. I'm sorry. So, okay. .7 and yeah, say we do 3.6, or I think in the book it's different. The label. 3.7 is
Okay.
derivatives of inverse functions. So they changed it, I guess. But I would say we do this section because it's super short, and we'll call it a day. The next week we'll do the harder section, and the one after that, because this is just formula based. Yeah, do you still have that calculus formula sheet I sent you?
Yes.
Okay, I'm gonna try to open mine, but open that up if you have it.
Okay.
Let's see here, 4 or 5 pages. Oh man. Let me show you what I'm talking about. Can you see this?
Yes.
So, where is it? It's like there was some sort of grainy thing under my mouse. It's just bothering me. Here we go. Common derivatives. See how it's inverse sine, inverse cosine, inverse tan? These
Yes.
are all formula based. So whatever x you have here, it's going to become this. There's another formula that's more complete that includes the chain rule, but technically you can just add it yourself, right? You do this derivative. Let's say the inside is 2x, right? You have a 2x in here, sine inverse of 2x. Let's just pretend. Take the derivative, you'd end up with this setup with a 2x inside that squared part. And then you do times the derivative of 2x, which is 2. So that would be your chain rule part, right? So over here, they're using the arc sine, arc cosine, etc. So it's the same thing as inverse sine, inverse tangent. It's just a different notation. This looks better on paper and it doesn't confuse
Okay.
people with negative signs, the negative powers. Uh, but in books, they like to use this because it's shorter, I guess. I don't know. Weirdos. But anyway, let's do that. I think once you see, I'm gonna give you the complete formulas of all of them because there was only 3 in there. It looks like.
Okay.
Derivatives of inverse functions. So derivative ddx of arc sine, in other words, inverse sine, is equal to derivative of x, whatever x is in here, take that derivative. So it's kind of like a shortcut. Divide by the square root of 1 minus x squared. ddx of arc cosine is equal to the same thing except there's a minus in front. You just plug in your x in here, take the derivative of x and put it up there. X being your argument. Okay. Arc cosine, or tangent, sorry, is equal to x prime over 1 plus x squared derivative of cosecant will be, well, let's do secant first, actually. Arc secant will be x prime over absolute value of x times the square root of x squared minus 1. Now let's do cosecant, which is the exact same thing, except you have a minus sign in front.
Can you move the paper up?
Oh, yes. Thank you.
Thank you.
Arc cotangent. Be the same as tangent except with a minus. Oops, it should be a quote.
Okay, got them all.
Okay. All right then. Okay. So let's go to the next page, I guess. Example 1. So let's say our function f is equal to arc sine of x minus 3. So take your derivative. The question would be find dy dx, I guess. So the derivative of arc sine of x minus 3 is equal to, so the formula says take the argument x, take a derivative of that, divided by the square root of 1 minus x minus 3. So 1 over 1 minus square this guy. So this becomes a 1, right? So it didn't really matter. It's gone. Square this dude and you're going to get x squared minus 6x plus 9. At that point, your derivative is technically done. But you could combine the terms at the bottom just so we're complete. Distribute your minus, and that'll give us this guy. Make it a minus 9 plus 1, that'll be minus 8. Yeah. Anyway, but you see what we're doing, right? You're just using the formula
Yeah.
here. That's it. Okay. Let's do another one. Find the derivative of f of x equal to 3 arc cosine of x over 7. So derivative of f is equal to formula says for cosine it's going to be negative, right? Derivative of your argument up here. Then on the bottom you have
Square root of 1 minus x squared in the formula.
yeah, that's right. So our x being this garbage. That makes sense.
Yes.
So at this point, you could bring this 7 down, do some algebra. You could technically force that 7 inside to get 49 minus x squared. See what I mean?
Mhm.
I think I forgot a 3. There was a 3 in front, wasn't there? Anyway, I skipped a few algebra steps. Is that cool? Or
Yeah, I get the gist of it.
okay. All right then. Let's look at the homework. Sorry if I sound exhausted.
No worries. I was lucky enough to talk with some people after my like short 30-minute nap, so my voice got warmed up. Otherwise, I'd be sounding worse.
Would you have to do?
Oh, I took a small nap while I waited for this class to start. I had to set like a million alarms to make sure I wouldn't sleep through
Telling you,
because I have
if you would have
slept
waited one more
for
minute, I would have ditched.
I haven't slept for 36 hours, so I was afraid that if I like went into like a good nap, I wouldn't wake up in time for class.
Yeah. I feel like if it's too much and then you just wake up exhausted, if it's just right, you feel energized. I'm just like, it's hard to
I'm
find
gonna
that
sleep for
sweet spot.
14 hours after this. I want to wake up and have it be 2 p.m.
Ugh, I hate that. Oh, 2 p.m. They meant like 2 a.m.
No, no, that's horrific.
I was like,
I'm on so
man,
many
you take too
sleeping
long of a
pills.
nap and then you just wake up right away.
It's great for me. I get alone time. Go outside, no one else is there. It's great.
True. It's great until you're exhausted by 5 p.m.
Yeah, that's true. Like no party time on those days.
Yeah, it happened to me last week. It was like, oh, what was it? I think it might have been that day, one of our class days. Like, you know what? There's no way I can make it after waking up at 3 a.m. But
I get it.
I forget what day it was.
Yeah. I think it was Tuesday last week.
Yeah, that might have been the day. I feel like it was.
Oh, I get it. My doctor had to put me on sedatives so I stay asleep.
Oh, that sucks.
Well, it's good now. She gave me sedatives and then she gave me a stimulant for when I wake up.
Oh,
So
that's
been
good.
living life to the fullest.
Nice. Well, do you have any questions on this approach? Do you see how we're just using formulas?
Yes.
Or do you want to do one more? Does this make sense?
No, that's clear to me. Yeah, it's just plug in.
Pretty much. Yeah, there's not much to say. I just wanted to make sure I gave you the formulas because they're not all here. And I think mine are better.
They are less complicated.
But this has most of the stuff though. Well, anyway, that's pretty much it for that section. The next one is the one's a little challenging here. So we're on week 6. We've done these two today. I feel like you understood pretty well. 3.7 is going to use the implicit ideas, but in general terms, like instead of doing with respect to X, it's going to do it with respect to time because it's going to be like real life problems, I guess.
I feel like I remember that one.
So you're gonna have like dy dt, dx dt, whatever.
Yes, yes, I do remember. Okay, good
So yeah, this
year.
is a little harder, so I'm gonna wait on this one until you've gone through 3-5.
All right,
Then we'll hit this one hard next week.
sounds good. And it's so
Mhm.
funny on my modules, it shows this is week 7.
Is it? I don't know.
Who knows?
It might be out of something might be off, but um next week we'll do yeah, related rates, Newton's method, and then maybe we'll do some exam 2 review.
All right,
And I should hopefully make some time to get those exams graded. I finished 2 other classes, but haven't got to this one yet.
no worries.
But I'm trying to do it in order as they came. We'll see.
Yeah,
Apologies,
totally get it.
it's been a while.